Hey, hello everyone. Welcome back to our YouTube channel. So first, I would like to take a moment to wish our beloved subscribers a very happy new year. May this year bring you the mastery and success that you deserve. And yeah, sorry for the delayed wishes. Anyways, so let's quickly jump into today's video. So in this video, we are going to discuss the CodeChef Starters 167 contest solutions. Let's start with the first question. Okay, so the first one, Happy New Year. Okay, the problem statement itself is Happy New Year. Okay, so currently it is X hours on December 31st, and you are wondering how many hours are left till midnight. Okay, for the purpose of this problem, we use a 24-hour format, so X can range from 0 to 23, it's obvious, okay. And you need to tell the number of hours left till the midnight. Okay, perfect. Now, here if you see, the value of X will range in between 0 to 23. Okay, now, as per the question, it is given that you are given a 24-hour format. Okay. Now, what is that one simple thing that you can do? What is that one simple thing that you can do? As you know that you are going to have a 24-hour format, and you need to know the number of hours left, right? So currently you're at X, which means the number of hours left will be minus 0, which is 24, which is same as expected. Okay, we'll go to the next test case. Again, 24 minus the current R, which is 23, which is 1, which is again same as expected. Okay, okay. I hope this is clear. And anyways, it's a simple question. Now, we'll make it generic. For every question that we are going to discuss in this um, video, what I want you people to do is, for every question, I'll just explain the problem statement, pause the video, see if you can do something on top of it. Okay, if no, again come back to the video. After putting your thoughts on the paper, come back to the video, resume it. We'll then discuss the logic. Once the logic is clear, again pause the video, uh, trace it down for any test case that you got stuck with, or etc. etc. And if that part is clear, you can start coding it up. Okay. Uh, Again, when you're typing the code, if you got stuck at any instance, you can again come back to the video and resume it, watch it. Okay, let's keep it generic, guys. Okay, pause the video, code it up, and come back here. Okay, yeah. It's discussed in the explanation. We'll implement the same here as well. So we need to read an input. We should simply subtract it from 24, and we have to print the same value. Okay, so simply print 24 minus the value that you are going to read. So simply int of input. That's it. Just a one-liner code. Okay, 24. Yeah, good to go. Yeah, that's it. Okay, we'll move to the next question. Okay, we'll move to the next question. Second question, delete not equal. Okay, we'll first understand the problem statement. Given a binary string S, we can perform the following operation as many times as we want. Just choose an index from 1 to length of S, where S of I is not equal to S of I plus 1. Okay, and you can delete either S of I or S of I plus 1. Okay, from the string, yeah, find the minimum final length of string S after performing some possibly zero number of operations. Okay, when you see the input format, first you'll have t test cases. Out of all these t test cases, you'll have to read an integer n and then followed by a string, binary string. Okay, cool. Now we'll just see here. We'll just see the constraints. First, t is at max 100 and n is at max 100, and the domain for s of I is only 0 or 1. Okay. Okay. Now, now First, we'll consider n equal to 1. We'll figure out what's the answer, and we'll go to n equal to 2. We'll figure out what's the answer, and so on. Okay. Now, first, we'll consider n equal to 1. For n equal to 1, what all possibilities we can have for s? This 0 itself is a s. Okay. And what else we can have? We can have 1. Okay. Now for this, what's the answer? As the length of n itself is 1. Okay. Then the answer will be 1. Okay. You can't delete any other character. So the answer will definitely be 1. Excuse me. Similarly, here the answer will be 1 for sure. Now we'll go to n equal to 2. Okay, now for n equal to 2, what all possibilities we can have? 0, 0, 1, 0. Okay, we'll go it in an organized way. So 0, 0, 0, 1, 1, 0, 1, 1. Okay, now if you see, here, can I remove this element? Can I remove this character? No, no, because the condition here says that s of I should not be equal to s of I plus 1. Okay, okay. Here the condition says that you have to remove either of s of I or s of I plus 1 only if s of I not equal to s of I plus 1. Okay, only if s of I not equal to s of I plus 1. Only then you have to remove. Okay, now if I consider I at this position, I plus 1 is same. Okay, I plus 1 is same. So I can't delete that character. Now when I move here, there is no I plus 1. Okay, so simply I can't remove any character from here. So this is the minimum possible string, which is 2. Okay, which is 2. Now, what about the next one? What about the next one? Okay, now I'll start my I at this position. Now, s of I is not equal to s of I plus 1. I can remove either of this or this. Even if I remove 0, the answer will still be 1. I mean, answer as in the length of string will be 1. Even if I remove 1, my remaining string is 0, which is still having length 1. So it doesn't matter whichever character I remove. So the answer will still be 1. Okay, now similarly for 1, 0, in the first attempt I can remove this. Still the answer is 1. Or, or I can remove this. Still the answer is 1. Doesn't matter, right? So your answer will be 1 for this case as well. Now, what about the next test case? What about the next test case? It is similar to this test case. So again here the answer will be 2. So what do you observe? What do you observe? If a string is having all same characters, okay, if same characters, you can't remove any other character. If same, you can't remove even one character from a string. Okay, so your answer will be the length of s. That's for sure. Okay, as the value of n is smaller, we'll consider a better one. Let's consider n equal to 3 now. Okay, for n equal to 3, what all possibilities we can have? We can have 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1, 0, 1. Okay, now what's the answer for this? You can't remove any character, so the answer will be 3 for sure. Now, what about this example now? There are multiple ways of deleting. We'll just see. Now, I'll start my I from here. Okay. Now, if I start from here, as they are not equal, I can't remove any of the characters. Okay. Now I'll move to here. Okay. Now I'll move to here. I can remove either this or this. Okay. Let's consider removing this. If that is the case, 0, 0 is our remaining string and I'll end up returning 2 as the answer. But it is not the case. We'll consider removing 0 now. Now what do you observe? 0 and 1. Again you can remove either of it. Now the answer will become either 0, or if you delete 1 you'll get 0. If you delete 0 you'll get 1, which means you're getting answer as 1. Okay. Okay. Now what do you understand from this perspective? What do you understand from this perspective? Okay, at least no. You might not be able to get that. Okay, we'll just consider answer as 1 for this and we'll continue. Okay, again 0 1 0 is now the case. These are not equal. Okay, these are not equal, so I can delete either 0 or 1. Okay, let's consider deleting 1 now. Let's consider deleting 1. In that case, the remaining string is 0 0, and you can't delete any character now. So the answer will be 2. Okay, now the problem statement says that you have to find the minimum final length of string s, right? So, so I'll consider the second option. What's the second option? To delete this 0. So previously I have deleted 1, so I got this 0 0. Now this time I'll delete this 0 so that I'll get 1 0. Again from this 1 0, as they are not equal, I can delete either this or this. If I delete 1, the remaining string will be 0. If I delete 0, the remaining string will be 1. So for both of this, the length of string is now 1. Okay, the length of string is now 1. Okay, now in this case as well, we got the answer as 1. Now we'll simply consider the next one as well, 0 1 1. Again from here, now just tell me which character I have to delete now from these two. Is it 0 or is it 1? It is 1 for sure. It is 1 for sure. Okay, in that case, only then I'll get two distinct characters. In that case, I can now delete any either of 0 or 1. Okay, you have to consider it that way. So in that case, I'll again get 1. Next, 1 0 0. Now which character will I delete? Now I'm going to delete 0. It's because in the next possibility, I'm able to uh, cancel out any of 1 or 0. So that I'll again end up having 1. Again here, 1 0 1. These two are not equal. With which character will you delete? I'm going to delete 1, because if I pair up 0 1, you'll get again you can delete any either of 0 or 1. Again you'll end up getting answer as 1. Again 1 1 0, 1 1 0. Now these two are equal. I won't delete anything. Now these two are not equal. Now what I'm going to do? I can delete either 1 or 0. What I'm going to delete specifically? 1, because in the next value of the remaining string, I'm able to delete either of 1 or 0, which will again I end up getting 1. Now the last case, which is 1 1 1, I can't delete any character from the string, so the answer will remain the length of the string, which is 3. Now what do you observe from here? What do you observe from here? Consider a random binary string. Let's consider 0 1 0 0, something like 0 1 0. Now we'll start from here. We'll start from here. Okay. Now if you see which character you want to delete now, 0 1. We should ensure that the string becomes as minimal as possible, right? So in that case, as these two are not equal, I'm gonna delete 0. Now 1 and 0, I'm gonna delete 1 or 0. I'm gonna delete 0. Okay. Now 1 and 0, I'm gonna delete 0. Now 1 and 0, I'm gonna delete. Now think about it. I'm gonna delete 1 this time. It's because I can now pair up 0 and 1. Okay. Now in that case, I'm now having 0 and 1. Again, these two are not equal. What I'm gonna delete now? Now this time I'm gonna delete 0. It's because in the next time I'm gonna pair up 1 and 0 which are not equal, and I can delete any of it. So the thing here is, the logic, the intuition here is that if there exists at least at least two different characters in a string, the answer will definitely be 1. Okay, if there exists at least 1 0 and at least one occurrence of 1. Okay, so even if you have 0 0 0 0 0 0 1, what I'm going to do first, I'll consider s of I, s of I plus 1. These two are equal. What I'm going to delete? This 0. Again, 1 and 0, this 0. Next, 1 and 0, this 0. The same way you'll delete this, you'll delete this, you'll delete this, and you'll end up having one uh, length string. Okay, so if there exists at least frequency, the frequency of 0 at least greater than or equal to 1, and frequency of 1 at least greater than or equal to 1. Sorry guys. The answer will be 1 for sure. Else the answer will be length of string. That's it. Okay, code it up guys. Pause the video. We will code it up. First we have to read t test cases, n which is length of string, and the string. Okay, for underscore in range int of input, n equal to int of input, and I have to read string s. Okay, now if the number of distinct characters in a string is equal to 1, then what would be your answer? Then what would be the case? Either you might be having all zeros or all ones. If that is the case, you'll simply print the length of string, which is n. Else we discuss that it will be 1. Okay, now the question is, how will you get the number of distinct characters in a string s? How will you get that? We can simply make use of a hash set. Okay, if length of set of s, if this is equal to 1, then definitely n we can print, or else 1. That's it. Okay, 1 to 1, which is same as expected. We'll just submit. Yeah, that's it. We'll start with the next question now. Okay guys, we'll start with the next question. Says temperature balance. Okay. There are n chambers of water in a line. Okay. Between the ith chamber and I plus 1th chamber for each I1 to n, there is a wall blocking heat from moving between the two chambers. The water in the chamber has a temperature level just each second you lift exactly one wall, letting heat move from between two chambers. The chamber having then the temperature level of hotter side decreases by 1, while that of colder side increases by 1. Formally, each second you choose an integer. Okay. If a of I is greater than a of I plus 1, you'll simply update a of I with a of I minus 1, and you'll update a of I plus 1 with a of I plus 1 plus 1. If a of I is less than a of I plus 1, you'll update your a of I with a of I plus 1, a of I plus 1 with a of I plus 1 minus 1. If both are equal, nothing happens. Okay. Minimum number of seconds needed to make all temperature levels exactly 0. Okay, got it. I'll just explain you the problem statement, guys. So we'll consider the first test case 1 0 0 minus 1. Okay. Now what he says is this A of I represents the temperature of water in ith chamber. in zeroth chamber, or if you consider one based indexing or zero based indexing, let's go with zero based indexing. 0, 1, 2, 3. So the heat of water in zeroth chamber is 1 degree Celsius. And similarly next 0 degrees Celsius, 0 degrees Celsius, and here minus 1 degree Celsius. Okay. So in the test case, it is given that sum of array will definitely be equal to 0, which is a valid test case as per the question. Okay, it will always be 0. Okay, now all you have to do is you should somehow make all the array elements as zeros. To do this, you're allowed to perform few operations in which if you want to consider these two chambers, here you can observe that a of I is greater than a of I plus 1. In this case, what happens is the temperature of this ith chamber is 1 and the temperature of I plus 1th chamber is 0. In that case, if you open uh, if you open the bridge between these two chambers, the water will obviously mix, right? The water will obviously mix. In that case, what happens is the container or the chamber which is having higher degrees will be reduced by 1. In that case, this will now become 0 and this will now become 1. Okay, that's what is mentioned in the question as well. Okay, if a of I greater than a of I plus 1, temperature of a of I will become a of I minus 1. I plus 1 will become I plus 1 plus 1. Okay, so in the first second, this is the uh, array. This is the updated array. Now, our goal is to ensure this. Okay, now we'll do the same thing again, 1 and 0. If I open these two chambers again, now what will be our answer? 0, 1, because the same case. Okay, now this is for the next second. Now, what about the next second again? 0, 0. Now, I'll connect these two chambers now. What will be our answer? 1 and minus 1 will be now connected. So, 0 and 0. That's it. How many seconds? For the first second, second second, third second. 3. That's it. We'll see the next test case now. Okay, which is 2, 0. Okay, we'll consider a simpler one. Maybe third is better, right? Okay, 2, 0 minus 1. Double 0, 1, 0 minus 2. Double 0, 1, 0 minus 2. Okay, now we'll just simulate. Okay, I'll connect these two chambers, which will be 1, 1, and everything remains the same. And what next? I'll open these two, which will become 1, 0, 0, and everything remains the same. Now what I'm gonna do? I'll just write it out. 1, 0 minus 2. For the next second, I can either move this or move that. Okay, let's consider moving this again. In that case, it will become 0, 1. I'll again consider moving these two, connecting these two, which will become. No, this is the updated one. Next, I'll connect these two again. Next, I'll connect these two again. Next, these two are equal. I can't do anything on top of it. Okay, now I'll consider this one now. Okay, or I can connect even these two. Anything is fine. Let's go ahead with this. Okay, now, what's the case here? 1 and minus 2. What do you observe here? A of I here is less than A of I plus 1. So what do you do again? A of I will be updated with A of I plus 1, and A of I plus 1 will be updated with minus 1. Okay? Okay, sorry, my bad. I have reversed the cases. Here it is greater, my bad. Okay, A of I is greater, right? So in that case, this will be reduced with 1 and this will be incremented by 1. I'll do the same. 0, 0, 0, 0, 1, 0, 0, minus 1. Now what's the next step? Now you should somehow combine this 1 and this 1, minus 1. So in the next second, it will become 0, 1. Again in the next second, it will become 0, 0, 1. Again in the next second, it will become 1 and minus 1, right? If we combine these two, it will become 0, 0, 0, 0. So how many seconds it took? This is first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11. Okay, so simply 11 seconds. That's it? Yeah, that's it. Okay, okay. Now, but how do you find this? How do you find this? Okay, let's consider the second example as well. 201, 201, 0000, minus 10, minus 2. Yeah, now we'll simulate and we'll see what happens. I'll combine these two in the first second, which will be 1, 1, 1, and everything remains the same. What next? Maybe I'll try to combine these two now. In that case, I'll get 1, 1, 0, 1. Next, I'm having something like this. Now, again, I'll combine these two, for which we'll get 1, 0, 0. Next, I'm gonna write, I'm gonna again connect these two, which will become 0, 0, 1, 0, minus 1, 0, minus 2. Okay, this is for the fourth second, and this is for the fifth second. Okay, huh. And so on. If you keep on doing this, you'll get answer as 23. Okay, you'll get answer as 23. But what do you understand here? What's the intuition? What can be the possible intuition? What can be the possible intuition? See, if you observe here, what exactly this 2 is looking for? What exactly this 2 is looking for? In the sequence, it should just look for minus 2. Either it can be minus 1, minus 1. Okay, even it can be even like this. Okay, if this is the case, if this 2 wants to be updated to 0, I mean the entire, if you want the entire array to be updated with zeros, this 2 is just looking for minus 2 sum from the remaining array. Okay, if we are having, let's say the next element as something like 3, what this 3 will look for? Some summation minus 3 from the remaining array, from the right of this 3. Okay, so that's how you should perform. Again, if you're having something like, again, maybe 10, this 10 will look for minus 10 somewhere in the right of 10. Okay, so that's how you should implement. Okay, for this, what do you observe? What do you observe? We can simply implement a prefix sum. That's it. Okay, we'll simply do a prefix sum for 1, 0, 0, minus 1. 1, 0, 0, minus 1. Okay, so what's a prefix sum? 1 prefix sum, right? I mean, you might know this. Prefix of I is equal to prefix of I minus 1 plus array of I. That's it. So prefix of this plus this, which is 1. Next, this plus this, which is 1. This plus this, which is 0. Now, what's the sum of this prefix sum? 3. So 3 is your answer. That's what we got. Again, we'll do it for this test case. 2, 2, I'm directly writing a prefix sum, okay? 3, 3, 3, 3, 3, and 2, 2, 0. Now, what's the sum? 4, 10, 16, 19, 21, 23. Just 23. Next, we'll also consider the third one, which is 2, 2, 1, 1, 1, 2, 2, 0. The sum will be 4, 5, 6, 7, 9, 11. Yes, that's it. That's it. We're gonna implement the same thing. But whatever we did, is that correct? Is that correct? We did a simple prefix sum. Will that work here? Think about it. Pause the video and think about it. Okay. So a simple prefix sum will not work. Will not work. For example, I'll tell you I'll explain you this part with a specific test case. Let's consider -2, 0, and maybe 2. Okay. In this case, what's the manual answer? First, we'll connect these two chambers, which will become -1, and here as well. What's the answer? What's the answer? It is -1. Okay, it's because we are just splitting these two and 2 here. Now, you might want to combine these two, which will become 0 and 1. Till now, we did 2 operations. Okay, here again, third operation, which will become 0 minus 1. And fourth operation, combining these two, 0, 0. So, total 4 operations you got. But again, we'll do a simple prefix sum, okay? -2, -2, -2 plus 2, 0. Now, what's the answer? It is returning you -4. What do you observe? Simply absolute of -4. Okay, but this is only working for this test case. Again, we'll consider some extended test case on top of it. 1, maybe 0, maybe -1, and 2. Okay, again here, what's the answer? If I combine these two, the temperature will become okay, here what do you get? -1, 0. Next, combining these two for the next second, I'll get 0, 1. Again, what do I do? And so till now, 2 operations done. Again, third operation, 1, 0. Next, fourth operation, 0 minus 1. Next, fifth operation, maybe these two again, 0 minus 1. Next, sixth operation, combining these two, you'll get 0, 0. So we got 6 as our answer. Again, we'll do a simple prefix sum. -2, -1, -1, again -2, 0. Now what's the answer? -4. 6. So yes, it is now working. Okay, we'll just implement the same thing in the code part as well. Okay, pause the video, implement the code, see if there is any issue with the code. Okay, fine. Okay, we'll type the code, guys. First read t, n, and array. Okay, for in range int of input, n equal to int of input, here equal to list of map of comma input dot split. And now first thing is we'll have to build a prefix array, right? So prefix array is equal to array of 0. Now we'll start from 1, index 1 to n. So prefix of 5. We'll just append, as it's an array list. We'll append the last element, which is prefix of -1 plus the current element, which is array of I. Okay. Now, now, again, what we are just doing, we are simply finding the answer for it. Okay. As we discussed a case where we got the negative answer, for which we'll just make it as this. Now, previously, I told you that there is another edge case as well, right? We'll see the test case. We don't know what's the answer, right? So, and this answer is nothing but the sum of prefix array. We'll simply run and see. 62 is the last test case answer. Okay, why is that so? Why is that so? I'll quickly debug and show it to you, okay? I'll quickly debug and show it to you. 60030. Okay, well, it's better if I write it here, okay? 60030 -40 okay, sorry, 000 -10 04. Okay, now we'll build a prefix on top of it, okay? 666 9 9 5 5 6 6 6 6 -4 -4 0. Now we'll simply find the sum of this prefix. 12 18 18 9 27 36 41 46 52 58 64 70 66 62. That's what we got in CodeChef compiler as well. But what exactly are we missing here? What exactly are we missing here? Here, if you see here, still having -4 and -4. But will you consider -4 values? I mean, they should be considered as +4s, right? So, for not the entire answer, you should you should consider the absolute value. Instead, what you should consider? Absolute value of prefix of I. In that case, what you would be adding? What you would be adding? So till here, the prefix sum was something like I don't remember. Okay, let's find it. Now let's find it concerning +4s. Okay, uh, 18, 27, 36, 41, 46, 52, 58, 64, 70, 74, 78. Yes. Now this is same as expected. So this is the edge case that I'm referring to. Okay. Now we'll just handle the same thing in our code as well. Okay. We'll handle the same thing in our code part as well. Okay. Now, huh. what's the change that you're going to do now? With this test case that you have here, let's consider some answer variable. Answer equal to, what will be our answer? Array of 0. Okay. Is it array of 0 or absolute of array of 0? What do you think? It is absolute of array of 0. It's because if first element as well as array of 0, it should be this. Next, answer plus equal to absolute of prefix of I. Exactly. Absolute of prefix of I. Now, anyhow, we are having a positive value for answer. There is no need of concerning this. You can now simply print this. That's it. Okay, we'll run. That's it. We'll submit. That's it. And small change to the code again. Array of 0. And we'll submit. Now the previously we discussed that it doesn't work, right? Yes, it doesn't work. Okay, that is the case. If the first element itself is negative value, it won't work. Okay, so it is mandatory to have absolute of array of 0. Okay, only then it will work. I hope you got this point right. Okay, now we'll jump into the next question. We'll start with the next question. Lottery tickets. Okay, there were n lottery tickets with numbers AI. Each number was distinct. Chef bought the first ticket, that is A1. He is now wondering whether he won the lottery. Here is how the winner is decided. A number X is decided in the range 1 to 10 per 6, and then whoever has the closest ticket to X wins the lottery. Okay, if there is a tie, all of them are winners. Okay, how many numbers X exist such that Chef won the lottery? Okay, so I'll just explain you this problem statement with a simple test case explanation. We'll consider the first test case 5, 1, 12. So here the chef picked this ticket. Okay, now you have to consider all the numbers from 1 to, okay, all the numbers from 1 to 10 power 6. Okay, now let's consider 1. Let's consider 1 now. Okay, if I consider 1, who is the winner now? Some other member who picked not ticket 1 will be the winner. Okay, now we'll pick 2. Okay, by the way, how are you deciding 1 is the winner? So as I'm starting from 1, what is the closest number in this array which is closest to 1? It is 1. So this player is the winner. As Chef picked as Chef picked the first ticket, so he won't win for sure. Okay, now we'll pick 2. For 2, what is one such number in the array which is most closest to 2? What is it? It is again 1. Okay, again for lottery ticket 2, 1 is the answer. I mean, E of I, ticket ID 1 is the winner. Next, for 3, who will win? What is the closest element in this array which is closest to 3? It can be either 5 or 1. The reason is the distance between 1 to 3 is 2. The distance between 5 to 3 is also 2. So in that case, what did he mention here? If there is a tie, all of them are winners. Okay, it doesn't matter if all the if everyone is a winner or not. That doesn't matter. You just need to know whether Chef won the lottery or not. That's it. Okay. So for 3, Chef can win for sure. Okay. For 4, what about 4? What is the closest number in the array which is closer to 4? 5. Here there is a single winner where the distance from 4 to 5 is 1, 1 to 4 is 3, from here to here it is 8. So there exists a single winner and Chef will win that. Now for 5, closest is this because distance is 0, distance is 4, distance is 7. So definitely chef will win for sure. Next for 6. For 6, again chef will win. It's because the distance is now 1, 6 minus 5, 1, and 12 minus 6, 6, and here 5. So closest is this, so chef will win. Okay, now similarly for 7, again for 7, chef will win. The reason is distance 2, distance 6, and distance 5. Again for 8, who will win? Distance is 3, distance is 7, distance is 4. Again chef will win. Okay, fine, fine. Now we'll go to 9. Again for 9, 4, 8, 12 minus 9, 3. Winner is 12. This. So chef won't win. Again for 10, from here on, whatever value that I pick till 10 power 6, this member will be the winner. Okay, chef will not win for sure. Okay, chef will not win for sure. Is that point clear? Now, in how many cases did chef won? At 3, at 4 as well he won. Okay, at 4 as well he won. 5 he won, 6 he won, 7, 8. How many cases? How many cases? 6 cases. So that's what you have to print. That's what you have to print. Okay. Now I'll simply debug it for the next test case as well. So 10 and 7 is now the test case. Ten and 7, right? Okay. 10 and 7. Okay. Now you have to pick. This is ideal. You have to pick from 1 to 10 power 6. Out of all these cases, where there is a possibility that the chef can win, you should simply write count plus plus. Cool. Now, I'll start with 1. Can chef win at x equal to 1? We'll see. Distance 9, distance 6. Okay. So, chef will not win. Okay, chef will not win at x equal to 1. What about x equal to 2? Again at x equal to 2, who will win? Distance 8, distance 5. So chef will not win again. Again for distance 3, for x equal to 3, distance is 7, and here it is 4. Chef will win. Chef will not win. Sorry. Again for 4, 6 is the distance, 3 is the distance. Chef will not win. 5. Again for 5, 5 is the distance, 2 is the distance. Chef will not win. 6, distance is 4, distance is 1. Chef will not win. For 7, distance is 0, distance is 3. Chef will not win. Again, for 8, distance is 2, distance is 1. Chef will not win. For 9, what about 9? What about 9 now? Distance is 1, distance is 2. Now, chef is having the closest distance, so the chef will now win at 9. Now, what about 10? Distance is 0, distance is 3. So chef will win for sure. Now, what's the expected answer for 11? I mean, what do you get for 11? Definitely chef will win because the maximum element itself is 10. So, definitely for 12, chef will win. 13, 14, 15, 16, so on till 10 power 6. Chef will win for sure. Chef will win for sure. So, overall, there are a total of 10 power 6. Out of this, how many is the chef losing? For 8 positions, he is losing. Elsewhere, he wins every time. So 10 power 6 minus 8, which is 9999992. That's it. That's it. Okay. Now this is for the second test case. Now we'll see the third one. We'll see the third test case now. Okay, now 3, 1, 4, 5, 2. X range will remain the same, 1 to 10 power 6. Chef picked this one, right? Okay. Now, for x equal to 1, who will win? This, there is no way chef can win this way. Next for 2, this is the closest distance. For 3, now chef can win. Now for 4, we're having direct 4, so chef can't win. For 5, chef can't win. No, for 6, 7, 8, 9, for all the elements till 10 power 6, which element is closest in the array? 5. So for all this, the player who picked this ticket will win. Okay, so there is a single chance, there is a only value of x, which is 3, and in this case the chef can win, so the answer will be 1. Okay, clear with this? Now the question here is, how would you solve this question? How to solve this question? First of all, how to solve this question? Okay, I'll just explain you. See, first put your thoughts on the paper, try for some time. If you're not able to crack the logic, come back to the video again. Okay, now we'll start discussing the answer for the first example. So 5, 1, 12. Okay, okay. Now, as chef picked this one, right? Okay. At any instance, what you need to know, if chef can win or not, how can you know whether, let's say, there is some particular value of x, which is at ith position. Okay, at this position, how would you know chef is the winner at this position? All you need to know is a number which is just lesser than 5 and just greater than 5 from the array. That's it. For example, let's say you have 0, let's say you have 20. Will this even affect our answer? No. It is enough if you just consider the next smallest element from array, which is 5, and next smallest element from um, next bigger element from the array, that is just greater than 5, which is 12. Considering these two are enough. There is no point in considering 12, 20, 30, 100 or 0. There is no point in considering these all values. It's because the problem statement asks you to check whether chef can win or not at that particular position. Okay. Now I'll just store something like k equal to 5 from the array. Okay. Now I'll sort it now. I'll sort it. Okay. Now I should somehow know the index of 5, index of this 5. So do you know any implementation which can help you get the index of it, index of some particular element k in a array? Yes, we can do a simple binary search. So upon doing a binary search, you'll somehow get the index of 5. Okay, let's say the position of it. Okay, the position of it is equal to 1. Sorry. Now, now the question here is, what next? Let's say some x equal to 7. Now, what do you do next? Think about it. Think about it. For how many values of x? Okay, let's consider x equal to 1, 2, 3, 4, 5. So in this range, definitely uh, it is clear that from 3 onwards, 3, 4, 5, considering x as these values, which are between 1 and 5, definitely a chef can win. The reason is 5 minus 3 by 2. I mean, 5 minus 3 is 2. Distance is 2. Okay. See, I'm just considering x equal to 3. Okay, what's the distance from here to here? 2. Here to here? 2. So chef can win. Okay. Now for 4, if 3 itself is a winning position for chef, 4 as well, chef will win for sure. Okay, it's because distance, if x is 4, 3 and 1, so chef can win for sure. If x is 5, chef can win for sure. So how do you write a simple mathematical expression on top of it? Okay, if the distance between these two are 4, how many elements that you'll have in between? Can I simply say by 2? I mean, in general you'll have 4 elements which are in between 2, 3, 4. If you consider 5, that will be 5. Sorry, 4. If you see, in between 1 and 5 you have 2, 3, 4. Okay, but here the question is, how many elements will be you'll have in between such that chef will win? Chef will win. So here if you see 2, 3, 4 are there. And if you also consider, as you are considering the winning positions 1 to 5, these at these 4 positions, chef can win for sure. Now, out of this, here he cannot win, and from here he can win. Okay, we'll also exclude this. So in that case, can I simply say he can win at how many positions from 1 to 5? Can I simply say 5 minus 1 by 2? Yes. And I have to also include this, right? So plus 1 plus. Now, as simple as that, from 12 to from 5 to 12, in how many positions chef can win? 12 minus 5 by 2. As simple as that. That's it. Our solution is done. Okay, what is 5 minus 1 by 2? 4 by 2, 2. 2 plus 1, 3. 3 plus, what is this? 7 by 2. What is 7 by 2? 3. So 3 plus 3, 6. That's it. That's it. We are done. We are done. Okay, but here if you say we'll see the next test case. We'll debug it. Okay, we'll debug. Okay, here if you see 10 and 7, right? So k will first store it k equal to 10. Okay, now we'll sort the array, which becomes 7 comma 10. Now now if I implement a binary search, my position will be at index 1, considering 0 based indexing. So I'm at index 1. What's the next step now? 10 minus 7 by 2. Okay. Okay. 10 minus 7 by 2. What's the value? 3 by 2, which is 1. And if I also consider this, 10 minus 7 by 2 plus 1 plus how many elements? How many elements will I have after this? Till 10 power 6, right? I can consider any value. I can consider any value from here. Okay. So the issue here is, if the value that chef is picking is the maximum value, then you don't have to write 10 power 6 minus 10 by 2. The reason is, from here on, every value that you consider, chef will win for sure. So how many elements are you having here? How many elements are you having here? So okay, first we'll say this. Here 3 by 2, 3 by 2, 1, 1 plus 1, 2, plus how many elements you have here? Till here I've considered everything. 11 to 10 power 6. How many elements? Simply 10 power 6 minus 10. These many elements we're having. So what is this value? 10 power 6 minus minus 10 plus 2 will be minus 8. And this is equal to this. Okay, that's it. That's it. Now, are we done with all the edge cases? Are we done with all the edge cases? No, not yet done. Not yet done. Not yet done. We'll see. Why? Okay, the next test case 3, 1, 4, 5, 2. Okay, okay. Now, Instead we'll have 1 3 4 5 2. Okay. Now if you see, what's the answer now? If I sort it, I'll get 1 2 3 4 5. I've modified the test case. Okay. um, k equal to 1 and your position will be landing at 0. Now if you see, there is no element towards the left of 1. What does it mean? And from here on, uh, obviously you have to consider 1 as a value. Okay, 1 plus, we don't know what's the answer towards the right. Okay, maybe okay, let's consider 13 14 15 12. In this case, now 12 13 14 15. Now what's the answer? 12 minus 1 by 2 will be your answer. Okay, this is the last edge case. So 11 by 2, which is 5, 5 plus 1, 6. So 6 will be your answer. This is the another edge case which CodeChef didn't give. Okay, okay. Now pause the screen. Code it up, guys. Okay, we'll start the code. First, as discussed here, constraints T and A. Okay, for underscore in range int of input. Okay, now I should consider n equal to int of input, and I have to read the array list of map of int comma input dot split. And now what's the first step that we did? You have to first store the k value, which is array of 0. Now I can store, like now I can simply sort the array. So k equal to sorted of array. No, I'll first consider answer as 0. No, no. Sorry. What should I do? I should first get the position from binary search. I should implement a binary search and I'll somehow get the index of it. So what were the edge cases that we discussed? If position equal to n minus 1. Okay, if what I mean to say is, if chef is going to pick the maximum element from the array, then you need not to implement array of position plus 1 minus array of position by 2, right? You can simply consider all the values which are towards the right of it. Okay, so what will I write now? What will I write now? So answer equal to 10 power 6. 10 power 6. Okay, 10 power 6 minus what will I write? What will I write now? How many elements are there towards the right? Array of position minus array of position minus one number of elements you are having. Okay, okay. Again. First, this is for the left part. This is calculating the answer for the left part. Okay. What I mean to say is, see here. If you see, what I'm doing is, if 7 and 10, first I'll calculate the answer for the left part, then I'll handle it for the right part. Okay. Okay. Now, what will I write? Array of position minus array of position minus 1 by 2. This is for the left part. Now, what should I do for the right part? I'll simply subtract those many numbers. Array of position. That's it. And plus 1. Plus 1. Okay. Plus 1. Why plus 1? For the current position you can consider. So, I'll better consider answer equal to 1. So, there is no need of writing it again plus 1 for if case, else if case, else case. Instead, I'll directly add it over there. Else if position is equal to 0, what will I do now? If position is equal to 0, what will I do? Can I simply write answer plus equal to? Answer plus equal to? What will I write now? What will I write? Think about it. Think about it. There I had 1. But instead, I might have something like 10, right? If I'm having 10, I can consider 1, I can consider 2, 3, 4, 5, 6, so on till 10 I can consider. So area of 0, area of 0 plus what will I write? Excuse me. Here if you see the test case, if I'm having the first one, now what will I write? Simply next position, uh, I should now find the answer for this part, right? This part I have to write. If I'm having 1, I have to write this part. I'll write the same thing. So which is area of position plus 1, which is 1 minus area of 0 by 2. That's it. By 2. Okay. Okay. Now we come to the else part. In the else part, what will you write? In the else part, simply answer plus equal to this left part. I mean area of position minus 1 by 2 plus area of position plus 1 minus area of position by 2. That's it. I'll write the same thing. Area of position minus area of position minus 1 by 2 plus now I have to consider position plus 1 minus position by 2. Position plus 1 minus area of position by 2. That's it. And then I'll simply print the answer. Okay, I'll run the code. Okay. Okay, BS is no. Okay, forgot. We completely skipped writing the binary search function, right? So I'll just pass array and the value that I have to search is k. Now we are going to implement a standard binary search implementation, guys. Low is at 0, high is at n minus 1. Now, while low less than or equal to high, what I'm going to do, I'll first calculate mid value, which is low plus high by 2. If area of mid is equal to k, I'll simply return the index of it, which is mid. Else if, else if area of mid is greater than k, what will I do now? I'll search somewhere on the left part. So I'll update high equal to mid minus 1. Else low equal to mid plus 1. Okay. As it is sure that it is for sure that k will definitely present in the array, so you'll definitely return mid in the process. So this is just a filler. Okay, that's it. We'll print, so it should give us 699. Okay, there is some issue with the code. We'll figure it out. Okay, I'm finding. Okay, here I'm passing into the binary search function. Instead, it should be okay. I'll better pass n comma k. That is even better. N comma k, right? Okay, n comma k. Okay, now this should work. So 6999. Okay, again there is some other issue. We'll see the code again. What's the issue? So the issue is when position is n minus 1, right? Okay, now what do we do? Okay, okay, understood. So if position is n minus 1, we are adding these many plus. Okay, this should be plus, right? This should be plus this minus area of n minus 1. You have to add it. Okay, I'll submit it. Okay, wrong answer. We'll see why. We'll see why. Okay. First k is area of 0. Okay, that is correct. Okay, as per the test case, that's what we have to write here as well. Okay, and what else we are missing? If position is in mid, okay, in the binary search function, if area of mid is equal, I guess there is no issue with the binary search code. 0 and minus 1, low less than high. If area of mid is k, Greater than k, I'll update this or this. Next, I'll sort the array. Okay, I'll first consider answer as 1. Okay, if now I'll consider this. Okay, I'll pass k to the function as well. Okay, even that is fine. Or without even passing, anyhow it works. If position is equal to n minus 1, if it is the last position, then I'll consider this 10 power 6 plus area of n minus 1 minus area of n minus 1 by 2. Okay, and again minus area of n minus 1. Okay, also if position is 0, I'll consider answer. Okay, then there is no need of again adding it, right? So here if you see, um, in this case we are also including 10, then it shouldn't be answer plus equal to, it should be instead answer equal to. I hope you understood this case, right? If this is 10, what we wrote is array of initialized answer to 1, and we wrote answer plus equal to. So you are considering this 10 again and again. That shouldn't happen, right? Now this should work. This should work. Yeah, that's it. Okay, we'll start with the next question. Grid construction, even. Okay, it says that you are given an even integer n. Okay. Okay. Even integer n. Next, your task is to construct a grid A containing n rows, n columns. Okay, n by n matrix, such that uh, every element in the matrix should be in the range 1 to 1 to n. And again, exactly n times in A. Okay. Okay. So, okay, we have to construct a matrix which is of size n, which is having the dimension n cross n, and every element in the matrix should range in between 1 to n, and also every element should exactly appear for n times in the matrix. Okay. Huh. Let the sum of elements in the diagonal from top left to bottom right is S1, and S2 be the sum of elements in the diagonal from top right to bottom left. Then sum of elements in every two adjacent rows has to be equal S1 plus S2. Okay, every two adjacent columns should be S2. Okay, so the problem statement is straightforward, guys. Let's say we consider see, n equal to 4. Okay, first we'll see the sample IO. Okay, in the sample IO, he says n equal to 2, right? Okay, we'll consider n equal to 2. Now we'll try to construct a simple matrix which is 1 to 1 2. Here, uh, this is not the matrix you have to print. There is another condition. There is another condition on top of it. Okay, we'll see the first diagonal. What is the first diagonal? This is S1, and this is the second diagonal, which is S2. So the sum of diagonals uh, are S1 plus S2. What is S1 plus S2? S1 is 3, S2 is 3. So S1 plus S2 is equal to 3 plus 3, which is 6. So he says that in the question, the additional condition is that every, what is that? Huh. Every two adjacent rows has to be equal to S1 plus S2. Every two adjacent columns has to be equal to S1 plus S2, which means sum of these two rows should be 6. Is it 6? 3 plus 3, 6. Yes. Okay. And also adjacent column 2 plus 4, 6. Yes, it is 6. So it is valid that you, it is valid if you write this. Okay. We'll just observe it from the test. Okay, for n equal to 2 it worked. Now we'll write the same for n equal to 4. Okay. Now what is the matrix now? 1 2 3 4 1 2 3 4 1 2 3 4 and okay 1 2 3 4. Now what is S1? S1 is 1 plus 2 plus 3 plus 4 and S2 is same 4 plus 3 plus 2 plus 1. My bad, sorry. Now what is S1? 10. S2 10. S1 plus S2 is 20. Now what about this adjacent row sum? 10 plus 10 20. Okay, satisfied. Now again what is the adjacent sum? Adjacent row is sum 20. Yes, satisfied. Next, what about the adjacent sum? 20. Yes, so it's satisfied. Now we should not directly print this. It's because we should also check this part as well. Okay, 1 1 1 1, which is 4, and again 4 plus 8. 4 plus 8 is 12, which is not matching, right? Which is not matching, which means this is incorrect. This is incorrect. Okay, we'll just see whether there exists any pattern from the output that he gave. Okay, now just observe the output pattern that he gave. 1 2 is same that we got. And in the next row, what did he write? He just reversed the first row. Okay, now we'll find the S1 and S2. Okay, now what is S1 and S2? S1 and S2 is 2 plus 4, which is 6. Okay, which is 6. Now, what is row wise sum? 3 plus 3, 6, matching. What is column wise sum? 3 plus 3, 6, matching. Okay, so this way he wrote. Maybe may not be valid for n equal to 4. We'll see. If that is the case, what do you write? 1, 2, 3, 4. Now you want to reverse it. 4, 3, 2, 1. Again you want to reverse it. 1, 2, 3, 4. Again you want to reverse it. 4, 3, 2, 1. Okay, now we'll see S1, S2, we'll see all this. Okay, now what is S1? 1 3 3 1. Okay, now what is S2? 4 2 2 4. We'll see if it works. Okay. S1 is 8. S1 is 8. What about S2? S2 is 12, which is S1 plus S2 is 20. Now we'll see the adjacent rows. Now 1 plus 2 plus 3 plus 4, which is 10. 10 plus 10, 20. Okay, it's satisfied. Okay, now what about the next one? 4 plus 3 plus 2 plus 1, 1 plus 2 plus 3 plus 4, 20 again. Okay, next. These two rows now. Again 20. Okay, it worked. Now we'll move to the column now. Okay, just remember that S1 plus S2 is 20. Okay. So this is S1 and okay, sum of S1 and S2 is 20. Okay. Now we'll see the columns. This is 4 plus 1, 5, 10. Okay. 10 and again 10, 20. Okay, it worked. Now we'll consider adjacent columns again. Again 10, 10, 20. Okay, again matched. Again here 4, 4, 8, 10. That's it, matched. Okay, that's it. So we are done with the question then. So all you have to do is just consider a simple array. So for n times, print the array once in a sorted way, next time in a reverse sorted way, next time in a sorted way, next time in a reverse sorted way. That's it. That's it. We are done with the problem. Okay, code it up, guys. Okay, we'll see the code. First, read T and M. That's it. Okay, for underscore in range of int of input. Now I'll have to read an integer n. Now I have to start considering the elements. So I'll just say some array equal to I for I in range 1 to n. Okay. Now what I did is just I've just stored the elements from 1 to n in an array. That's it. Now for I in range of n, if I is even, print in a sorted way, else print it in a reverse sorted way. Okay, as n is even, right? So we can even do it this way. So n by 2, while iterating for n by 2 times itself, I'll print it in a sorted and reverse sorted in a same instance. Okay, I'll print everything in array, and also I'll print everything in array in a reversed way, reverse sorted way. That's it. I'll run the code. Should give 1 2 2 1. Yes, I'll submit it. Yeah, that's it. It worked. Okay, such a simple code, guys. All you have to do is just observe it from the question. Okay, we'll move to the next question. Grid construction this time. Okay, it is now odd. I guess everything except this, everything is the same. I guess. Yeah, everything is the same. So, so it is highly recommended to solve the previous question first and then come to the current question. Okay, first solve that question and then come to this question. Okay, now, okay, here as well, we'll directly try to find a pattern that exists in this sample IO. Okay, as n is 3, you got this output. Okay, we'll see what all things that we can grasp from this output. Okay, first thing is, okay, this is a matrix for sure. And again, it is very clear that the transpose, it is a transpose matrix, which means a bar t is still a. Do you observe that? Do you observe that? Okay, even if you transpose the matrix will still be the same. That is a property here. Okay, and again, if I deep dive more into this, the first row I'm having 1 3 2. Okay, as of now I don't know why I wrote 1 3 2, but as per the output that it has, I'm just writing the same. So in order to get the next row, which is 3 to 1, what exactly you think they have done from first row to second row? Sorry, guys. They just popped the first element and attached it to the end. That's it. Okay, so that's how they got this. Now, what can be the next one? They'll again remove this. They'll write the remaining 2 1 and now attach the last one, which is 2 and 3. Is that same? Yes, it is same. So that's how they wrote. Okay. Now, uh, first we'll validate whether everything is working or not. I mean, working as in um, this S1 plus S2, all those things, we'll see if we can validate that. Okay. Okay. What is S1 plus S2? Okay. This property, um, for a current row, first, this row is nothing but what I can simply say, from this row to this row, what's the change? Maybe if I consider it as an array, what exactly is happening? Array dot append, I mean, that is row, right? Okay, row dot append. What am I adding at the end? The popped element from the first index, row dot pop 0. For every row, this is what it's happening. Okay, again, if you move to the next row, this row is again getting updated with the same property. Okay, okay. Now, now, we'll see S1 and S2. What is S1? 1 plus 2 plus 3, which is 6. Next again here, 2 plus 2 plus 2, which is 6. Overall, I have 12 now. Okay, now we'll see. We'll see the rows. 1 plus 3 plus 2, 3 plus 2 plus 1, which is 6 plus 6, 12, validated. Now 3 plus 2 plus 1, 2 plus 1 plus 3, 6, validated, yes. Next from here, 1 plus 2 plus 3, 3 plus 2 plus 1, 6, validated. And again here, 1 plus 2 plus 3, 1 plus 4, validated. So 12, okay. Okay. Now, I'll just consider this part, this way now. Okay, I'll consider 1, 2, 3, and what I'm gonna do now, I'll remove this and I'll attach it at the end, and I'll simply write the remaining, which are 2, 3. Okay, next, what I'm gonna do, I'm gonna write 3, 1, and I'll remove it and add it at the end, which is this. And now this is a transpose matrix. Transpose of it is also the same. Okay, now I'll try to validate it. Okay, now I'll try to validate it. 1, 3, 2 and 3, 3, 3. Okay, now what is 1 plus 2 plus 3? 6. 6 plus 9, 15. Okay, so S1 plus S2 is 15. We'll see if it is being matched. Sorry, guys. Okay, 1 plus 2 plus 3, 1 plus 2 plus 3 is 6 plus 6, 12. So it's not matching. This is not correct. This is incorrect. Okay, this is incorrect. We shouldn't randomly pick any transpose matrix. We just build the first row, and then we're just finding we're just constructing the remaining rows, so which is not working here. Okay, so what should I do then? What should I do? I should consider every rotation of this as a first row. Okay, so here I've started with this. Okay, here I've started with this, but that won't work here. That won't work here. Okay, instead you should only start with this. How will I get that? How will I get the first row? If I can somehow get the first row, my task is done. Okay, if I can somehow get the first row, my task is done. Now, what do you think can be the answer for n equal to 5? For n equal to 5. Okay, we'll first consider n equal to 5. Obviously, it is clear that writing 1, 2, 3, 4, 5 and constructing all the remaining rows will not work here for sure. Okay, so this specific problem is purely based on observational process. Okay, so first there is some pattern over here. Okay, which is first, for n by 2 elements you have to consider it some way. For the remaining n by 2 elements you have to consider in some other way. Okay, every time what you need to do is you should start from 1 for sure. There is no alternative for that. Okay, now what is n by 2? 5 by 2 is 2. So till 2 you have to simply write till there, and from here on I should consider the reversed element 5, 4, 3. Okay, that's what I've done there as well. Okay, now I'll just consider the updated rows for the remaining elements. 2, 5, 4, 3, 1, and next 5, 4, 3, 1, 2, next 4, 3, 1, 2, 5, next 3, 1, 2, 5, 4. Okay, now what is S1? 1 plus 5, 6, 6 plus 3, 9, 9 plus 2, 11, 11 plus 4, 15. Okay, 15 I'm having. And next 3 into 5, 15. 15 plus 15 is 30. Okay, so 30 I got. Now, what is S1 plus S2? 1 plus 2 plus 3 plus 4 plus 5, 1 plus 2 plus 3 plus 4 plus 5. That is simply 2 into n into n plus 1 by 2, which is 5 into 6 by 2. Huh. Now this is 30, which is same as expected. Okay. Now here if I move, again 1 plus 2 plus 3 plus 4 plus 5. Again 1 plus 2 plus, okay, 30. Okay, and again here 30. Okay, it is matching. Now I'll consider rows. 1 plus 2 plus 3 plus, again, simply working. Again these two working. Again these two working. Again these two working. Okay. So what I did here is first build a n by 2 elements. Okay. First build a n by 2 elements. Okay. Let's say if n is something like 9, do it till n by 2. What is n by 2? 9 by 2 is 4. So first build 1, 2, 3, 4. Okay. If n is equal to 9, if n is equal to 9, the first row should be built something like this: 1, 2, 3, 4. And from there on, 9, 8, 7, 6, 5. This is how you should build the first row. Only then, see, the reason why we are doing this is, see, you may also cross question this. You may get a doubt that uh, how am I able to come up with this conclusion? The core reason is what I'm doing here. I'm more or less having 1 here, 2 here, 5 here, and in the next row I'm just um, removing this element and updating at the end, right? So it is very clear that I have to balance this balance of 1, 2, 3, 4, 5 in a single column. In the same way, in a single row, it will anyhow be balanced. Okay, for the same reason, I'll first add it at the end. Okay, now core intuition that you have to observe here is upon some rotation, your 5 will somehow come to here. Okay, and next 4 will somehow come to here, 3 will somehow come to here, and you have to balance them with 15. You must have 2, right? That's the only option that you have. So that is purely obviously it's a trial and error method which worked. You have to build such pattern on your own. Okay, that is the core intuition here. Okay, uh, I mean, there can be many trial and error method where you land to the false logic building, but fine. But still, try to come up with this kind of approach where you what you try to do here is, let's say you're able to build 5, let's say you're able to build 4, let's say you're able to build 3, and to reduce it still while removing an element from the first index and adding it to the end. So in some rotation, definitely you'll get 1 and 2, right? So that's exactly how we're doing that, and that's what I got here as well. 5, 4, 3, 1, 2. Okay, so that's some core intuition here. Okay, now how do you code it up? Code it up, guys. We'll quickly code it up, guys. For underscore in range int of input, I'll first read the value of n, which is n equal to int of input, and now I have to build the array. So how am I gonna build that? For I in range 1 to n by 2, right? I have to consider all these values. Sorry, guys. Array dot append I. That's it. And now I have to consider all the remaining values in a reverse ordered way, which is n by 2 to, sorry, n to n by 2, not n to n by 2 to, right? N to n by 2, I have to reduce the value of I. Okay, that's it. And now for I in range of n, what am I going to do? First, I'll print the array referring to the first one. Now, array dot add. What will I add? Removing the first element, and I'll add it at the end. That's it. I'll run the code. Okay, 132.321.213. Okay, that is same as expected. We'll we'll submit it. Correct answer. Okay, one small optimization that you can do here is, so here a pop operation, I mean, if you're deleting from the end, it will take off one time. But as you're deleting it from the first index, it will take n time. It's because you're shifting all the remaining elements to the left. So instead, what exactly are you doing here? You're adding an element at the rightmost end, you are deleting an element from the leftmost end. Uh, a simple alternative here is you can implement a deck here from collections, import deck. Okay, deck is nothing but a double-ended queue where you can do CRUD operations from both the ends. Okay, now instead of array, what I'm going to do is some dq equal to deck of an empty array. Now instead of array, I'll write dq. Okay, dq dot append I, and again here dq dot append I, and here dq dot append at the end. And where are you popping from? You're popping from the leftmost end, right? You don't have to now specify the index. That's it. Now this is way faster than the previous. Okay, instead of array, I have to print deck, right? Deck elements. So dq. That's it. So this star symbol simply represents that we have to, we're just printing all the elements present in a particular data structure. Okay, here as well replace array with dq. Yeah, that's it. Submit. That's it. That's it, guys. Okay. Huh. So this is the first implementation and this is the second. Let me just show my submissions. And 3 minutes ago. Huh. So this is the one. This is the one with the array implementation, and that is with the deck implementation. Okay, guys, note it down. That's a wrap for this video, guys. We hope you enjoyed it and found the solutions and explanations clear and insightful. Don't forget to subscribe for more engaging content. Yeah, thank you, guys.